Okay, so we're definitely starting to hit some more intense questions now that require a bit more memory of what we've covered. Question 9, we have a piece of machinery that's initially worth $56,000. So again, we always want to highlight any numbers that we're given. We know it depreciates, and that depreciate is to go down in value at 8% per annum. I'm going to highlight that as well. So the question is, which graph best shows the salvage value? You can figure out that's just going to be the price of this machinery over time. Okay, so we've got 4 options to look at. The first thing I would hope that you would realize in this question is that if something's going to go down by 8% each year, it's going to be going down by a smaller and smaller amount. Okay, it's kind of like that silly cartoon of the hamster that goes in to get his hair cut. It's 50% off, and each time he gets 50% off, he gets half of his hair. And you can picture that and say, well, half and then half and then half and half. He's never going to get rid of it all, but the amount that's taken off gets less and less and less. And that silly idea is basically all you need to answer this question. You need to realize straight away that it's not constant. It's not going to be a straight line. It's not going down by $20 each year, for example. So it's not D, because a straight line is constant. So we're looking at either A, B, or C. The only other thing that you need to realize is that if you're thinking about a car, for example, and it depreciates by 8% each year, it's never going to be worth nothing. It's going to be worth less and less and less to the point where it's near nothing. You may as well just scrap it, but it's never going to be worth nothing. So this C answer here, where it clearly hits a value of 0, that can't be right. Okay, and then you can see B and A are both very similar. Now the reason the answer is not B is kind of tricky. It's a bit of intuition. You can see that B goes down very, very quickly. Okay, it doesn't look like it's going down by 8%, which is quite a small amount each year. The other thing that kind of bothers me about B is that it basically reaches 0. It doesn't necessarily, it gets very close to like existing at the bottom there, but it's basically 0. So that seems to have dropped a little bit too quickly. So that's why I'm going to go with answer A. Okay, and that is the correct answer. For reference sake, I'm not guessing, but that's how I would figure that question out. I'd start by saying it's not constant, it shouldn't be 0, and it sure as hell shouldn't drop that quickly. Okay, it's still a $56,000 car. Okay, so question 10. We have the length of a fish, which was measured to be 49 centimeters. And it's important here that it says it is correct to the nearest centimeter. So that means we're counting by centimeters. So 49, 50, 51. Okay. It wants to know what is the percentage error in this measurement correct to one significant figure. So there's actually quite a lot going on in this question. Okay. The first thing you need to realize whenever you see error in measurement, we're always going to start by thinking about our absolute error. Now, absolute error is just saying if I'm counting by centimeters, so 49, 50, 51, 52, or I can go backwards and say 48, 47, okay, my absolute error is always going to be half of what I'm counting by. So in this case, it's going to be half of 1 centimeter, okay, which will be 0.5 centimeters. That's definitely a tricky idea at first. An easier example might be if I was measuring to the nearest meter and I had 24 meters. Okay, my absolute error there, I'm counting by meters, so my absolute error is going to be 0.5 of a meter. You can see it's pretty much always going to be something with a 5. It's not necessarily always going to be 0.5. So if we did something like 49.1 centimeters, and you can see there I'm counting to 1/10 of a centimeter, or 1 spot after the decimal spot. So my absolute error in this case, basically what you need to imagine is this is kind of like a a 49.10. And I'm counting by tens, okay? So the next one will be like 49.20, 49.30. That's basically what I'm counting by. Then my absolute error is going to be half of that 0.10, which would be 0.05. That's a quick summary of absolute error. It's a little bit tricky, but once you get down, it's just half what you're counting by. Okay. So if you can get that, this question isn't too bad. We know it's 0.5 centimeters. Next, when we do percentage error, okay, we're always going to grab our absolute error, our 0.5. We're going to divide it by the only other number we're given. So if you kind of forget the main idea here, you're going to find your absolute error, and then you divide by the only other number we've got, which is 49. That's the actual measurement. Okay. If you type that into your calculator, you'll get an answer. You can do this now or you can do it after. We're going to times it by 100, only because we're asked for a percentage. And that's how we get a percentage from a decimal. So you can do it now or you can do it after you've hit equals. That should give you 1.02, blah, 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 blah. And remember that that is our percentage. Okay. So the problem here is that we are looking for one significant figure, which basically just means rounded to one number. So it clearly can't be A or B. So we're going to look at C or D. Okay. And all we have to think about is this 1.02 blah, 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 blah. Is that closer to being 1% or closer to being 2%? And hopefully intuition tells you that should be closest to 1%. So that's our answer. Question 11. This is a line question, and it's solely to do with the equation of a line. So there's only two things you need to know about the equation of a line. It's always going to be written as mx plus c, okay, where this m is our gradient, and gradient is just how it's changing as rise over run. So how far it's gone up or down divided by how far it's gone across. The other value c is our y-intercept, so where it hits the y-axis, okay, that one there. And another way to think about that is kind of like its starting value. For most of the graphs that we look at in standard, thinking of it as its starting value is going to be really helpful. So the first thing you should be able to spot is that our equation has a y-intercept where it hits that axis, or a starting value of 2. So my equation is going to have a plus 2. Now, sometimes that might narrow down your options, but you'll notice that every single one here has a plus 2. So a good sign that we're in the right direction, but it doesn't really help me. So I need to get this gradient. So remember that gradient is rise over run. So how far you've gone up over how far you've gone across. So starting at this point here and getting to this one here, you can see that I haven't gone up, I've actually gone down. And I've gone down 2 places. So my gradient is actually going to be 2, but minus, because I've gone down. So I've gone down to minus 2. And from this point here, that 0, you can see I've gone 1 across. Now, if you're not too confident with your fractions or your basic maths, I would type that into my calculator. Even if you are confident, it's always just good to double check. So as a fraction, you get minus 2 over 1. That's going to pop out an answer of minus 2. So that's a number that sits just there in front of x. And hopefully we can go through A, B, C, D and find one that matches up perfectly.